All right, section 2, Swyk 2. Now, if you see a logarithm, which you will see many of the logarithms out there in the universe that don't seem to have a base, it's like, come on, what's wrong with that? I mean, if you like it, then you put a base on it. I mean, isn't that what the song says? All right, so it's called a common log. And a common log is always base 10. You have to understand that. So, many times, we write things like x. Well, we say things like, what's the coefficient? What's the exponent? Everybody knows it's a 1. Well, in logarithm land, if the base is not written, it is always a 10. It's called a common base. Okay? Just wanted to point that out to you. Now, I've got to, move over here to the side because I got lots of good stuff to show you. We need to talk log properties. All right. Now, log properties, there are 3 and 1 extra, so a total of 4, but the 1 is separate from the other 3. The log properties that we're referring to allow me to change something from an expanded logarithm back to a single logarithm, or from a single logarithm back to an expanded logarithm. Okay, and I'll explain the difference. You are familiar with the song I just referenced, right? All the single logs, all the single logs, all the single logs, all the single logs. Whoa, oh, oh, whoa. Anyway, so what's the rule, or what in the world, how do we determine what's a single logarithm? Well, number one, all the terms are together. Okay, but the second thing is that the coefficient, that's the number that's in front, the multiplier in front of a logarithm, is a 1. Those are the criteria for having a single logarithm. Now, so what's an expanded logarithms? Well, that means that all the arguments are separated, and we'll talk more about that in a minute. And the arguments all have an exponent of 1, which will make sense more in a little bit. Okay, let's scroll down here and look at our. So on the left side here we have single logs, and on the right side we have expanded logs. And the properties go like this. You can take the product and you can split it into a sum of 2 separate logarithms. Now, likewise, if you're going the opposite direction, you can take the sum of 2 logs and you can put it back together into 1 log of a product. Now, it's not log times log. That's not what it says. It's taking these arguments, the a and the b, in 2 separate logarithms, and it's multiplying them together into one product and taking the log of that product. Well, if that's true, then if you go to number 2 here, the logarithm of a quotient can be split up into subtraction, right? Log of the numerator minus log of the denominator. Now, I want you to know, and I want you to notice, in every one of these, the base does not change. It stays exactly the same. The 4th property that we're going to talk about is called a change of base theorem, but that has nothing to do with these 3. That's why these 3 are kind of their own. Oh, sorry, too sleepy. The 3rd property was, there's actually a song about this 3rd property in the movie Madagascar. Hold on a second while I remind you. You remember King Julian from Madagascar? Yeah. What was his song? I like to move it. You like to move it. We like to move it. Move it! All right. Sorry, I accidentally hit the pause button even in my own song. That's terrible. Okay, so why is that so important? Let's go back to the math. So what he was really singing about was taking the exponent of the argument and moving it down as a coefficient, or taking the coefficient and moving it back as an exponent. It's the move it property. And if you need something to be a single logarithm, then you move that coefficient up and make it an exponent. If you need to make an expanded one, where the exponent has to be a 1, then you move it back down as a coefficient. So you can interchange the exponent and the coefficient all day long if you want. Be kind of a boring life, but you could. Okay, next. The change of base. We're not going to get into this right now, but we will eventually here. The change of base theorem allows me to take any logarithm. This is why I separate this one, because the other ones keep the same base all the way through, but the change of base allows me to pick my own base. Now you might be saying right now, why would I want to change the base of a logarithm? Because our calculators are only able to do base 10 and base e. Now, I know you're saying to me right now, well, I know the number 10. What the heck is base e? All right, well, e is actually a number. It was named after this really cool mathematician, and we'll get into it later. I wouldn't want to talk about it right now. Okay, but your calculator has those two bases programmed into it. So when we get to stuff that we cannot do without a calculator, we're going to be using this property right here. And most of the time we choose base 10. But we can choose base e. Our calculators do both. Anyway, so let's get into the rest of the math. Man, I know that was a lot of information just to get to this problem. So this is going to be a longer video, so I apologize. Log 3 plus log 2. So anyway, we want to multiply. When we see the addition right here, we want to multiply the 3 and the 2, right? So the 3 and the 2 come over here, and they get multiplied together. Sorry, the arrows are going to the wrong place, but that's okay. You understand what I'm talking about, because multiplication is commutative, right? You can switch them. Sorry. So log 6 is the answer, because they wanted a single log. That's all they wanted was a single log. And the coefficient is a 1. That's good. Question 7. First thing we're going to do is we're going to deal with this coefficient using the move it property. We'll bring it up here and make that 7 squared. 7 squared, of course, is 49. Then I see that we have addition, right? So what is that telling me to do? It's telling me to multiply the 49 and the 4 together, giving me log 196. And believe it or not, that is the answer. They just wanted a single log. Now this is base 10, so I could type this on a calculator and I could get the really weird decimal, right? Because we know that that a logarithm is an exponent. Sorry for yawning. Try to suppress it, but it didn't work. Now when you get really good at this kind of stuff, you're gonna move that exponent up, and right about here you're gonna jump to there, and then you'll come right to here. Okay. Once you understand what you're doing, you will. I know you will. Happens to a lot of people. Okay, so question 8. The good old simplify. It's multiple choice. We got log base 8 of x over y. Yes, that is log base 8 of x minus log base 8 of y. Using the property, we changed it into its expanded form. Well, what about this one here? We got log 64 times a times u times r. Okay, you'll notice I put parentheses around it because it's all the argument is 64 AUR, all that together. Now, so we know we can split that up into log base 8 of 64 plus log base 8 of a plus log base 8 of u plus log base 8 of r. But that answer is not listed anywhere. So I get really super confused. Well, wait a sec. I know that's the right answer. Well, they're kind of doing a little bit of a trick to you. Log base 8 is 64 is something you can simplify. Remember, the base is 8, the exponent is x, and the argument that it equals is 64, which is none other than 8 squared. Therefore, x equals 2. So that whole thing can be simplified to 2. which is why answer choice B was the correct one, because ding, 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 they simplified that part. Who would have known they were going to do that? Anyway, I just thought I'd share. Okay, so 10's pretty easy, right? Log base 7 of AB, that's log base 7 of A plus log base 7 of B. It's multiple choice. You're going to do fine with that. And that's it.